You've seen it happen, right? An AI demo looks absolutely mind-blowing, but the second it gets into the hands of real users, it just falls apart. Well, today, we're going to get into exactly why that happens. We're leaving the clean room behind and diving headfirst into the messy, chaotic world of production AI.
So you've built a RAG pipeline, a retrieval augmented generation system. On your laptop, it's a genius. But when actual people start using it, it's slow, it's wrong, it's a total disaster. Sound familiar? This isn't just some random bug. It's a huge disconnect between the lab and reality. So let's figure out what's really going on under the hood.
To really get to the bottom of this, we're going to put on our architect hats. We'll walk through the exact kind of gritty, real-world problems that AI architects have to solve every single day. We're talking about the tough calls, the high-stakes decisions, and the critical trade-offs that make or break a project.
All right, here's our game plan for today. We'll kick off with a big challenge of just going to production. Then we'll break down the pipeline piece by piece, getting data in, getting info out, and keeping the whole thing running smoothly. And trust me, we'll be talking a lot about balancing those tricky trade-offs that every architect needs to master.
So, what exactly is this production challenge? Well, think of it like this. A demo is like driving on a perfect empty test track. Production is like navigating a chaotic city street during rush hour in the rain. Your system has to be ready for thousands of users, weird questions you never expected, and a constant fire hose of new data, all without crashing and burning. And you know, right at the center of that whole challenge is the data. You can have the fanciest AI model in the world, but if your data foundation is shaky, the whole thing will collapse. So let's start at the very beginning, building a data ingest pipeline that's clean and rock solid from day one.
Let me paint you a little nightmare scenario. Your pipeline is chugging through a terabyte of new logs, but there's a silent bug, and it's reprocessing old data over and over. What's the result? Your vector database gets bloated with duplicates. Suddenly, your search results are junk, users are losing trust, and your costs have secretly doubled. This is the kind of silent killer that can absolutely destroy an AI project.
So how do you prevent that nightmare? You build a workflow that's designed like a tank. First, you pull in the raw logs from something like S3. Then, you bring in a heavy hitter like Apache Spark to get rid of all those duplicates and clean things up. Next, a tool like LangChain chops the data into smart chunks and creates the embeddings. And finally, you load all that clean, pristine data into your vector database, like Pinecone. Every step has a purpose.
But here's the catch. There's always a catch, right? Using Spark is super reliable, but it might take a full hour to get through that terabyte of data. On the flip side, you could use a real-time tool like Flink and get it done in 5 minutes. The problem? Flink is way more complex to manage. So, as the architect, what do? Is that near-instant data worth the extra headache?
Okay, so our data is clean, it's organized, it's beautiful. Fantastic. Now for the next giant hurdle, getting the right answer out of the system and getting it fast. This is where we run into the three-headed monster of production AI: latency, relevance, and, of course, hallucinations. So here's the new problem. Your system takes half a second to answer a question. Now, that doesn't sound like much, but to a user, it feels like an eternity. And even worse, when the answer finally arrives, 15% of the time, it's just wrong, completely made up. Your users are getting annoyed and your project's credibility is tanking. To squash that latency, you've got a choice. It's kind of like your home's thermostat. You could go serverless, which is like an automatic thermostat. It scales up and down perfectly on its own, which is great, but your bill might be a surprise. Or you could use dedicated pods, which is like setting the temperature manually. Your cost is totally predictable, but you're the one who has to manage it. And what about those hallucinations? Well, the best way to fix them is to give the AI more context, more info to work with. But that costs a lot of money. So you can use a clever trick called context compression. It's like giving the AI the highlights instead of the whole book. It can slash your costs by, say, 40%, but you might lose a tiny bit of accuracy, a little bit of what we call groundedness. Is saving all that cash worth a tiny risk? That is the kind of question an AI architect lives and breathes. You know, building a great AI system is really only half the job. Keeping it running perfectly for months or even years, that's the real test. Building it is a sprint. Now we're talking about the marathon. Welcome to the world of LLM Ops. And in this marathon, one of your biggest enemies is a sneaky little thing called data drift. It's what happens when the real world keeps changing, but your AI is stuck in the past. People start using new slang, your company launches new products, and your AI is clueless.
its performance just slowly starts to rot from the inside out, often without you even noticing.
Yeah, you have to think of your AI like a garden, not a statue. A statue you can just leave alone. A garden needs constant attention. Without robust monitoring to spot this drift, that brilliant model you built can become useless. The real solution is to build systems that not only warn you about drift, but can automatically kick off a retraining process to keep your AI sharp and up to date.
So, we've talked about getting data in, getting answers out, keeping things healthy, and you've probably noticed the common thread here. It all comes down to one big, complex balancing act. Being a great AI architect isn't about perfecting one thing. It's about becoming a master juggler with a dozen competing priorities.
This quote right here really nails it. MAP, that's just a technical term for search accuracy. So you want more accurate answers? Simple. You give the AI more context, more stuff to read. But the more it has to read, the longer it takes. So your accuracy goes up, but so does your latency. It's a classic seesaw. When one side goes up, the other side has to come down.
So how do you stop guessing and start making smart choices? You use a tool like this, a decision matrix. You start by setting clear goals, your service level objectives, or SLOs. It's like your system's report card. And look, you can see right away where you're failing. Accuracy is too low? Let's try a re-ranker. Hallucinations are at a crazy 18%? Okay, we need stricter prompts. We're too slow? Let's experiment with smaller chunks. This turns chaos into a clear engineering problem.
And don't ever think this is just about tech for tech's sake. We are talking about serious money. $1.2 million per year. That's the kind of savings a team actually found by getting these trade-offs right. This isn't just about building cool stuff, it's about delivering huge, measurable value to the business. Okay, so after going through all of these challenges, what's the big takeaway? It all boils down to adopting a production mindset from the very first line of code you write. It's a huge shift from thinking, can I build a cool demo? To asking, can this system survive in the wild for the next 5 years? So what does that mindset look like in practice? It's these 5 principles. First, define what success even means with clear SLOs. Second, measure everything: latency, accuracy, cost. If you can't measure it, you can't improve it. Third, learn to love the trade-offs. They're not a problem, they are the job. Fourth, be paranoid about data drift. And finally, automate, automate, automate. Because every time a human has to intervene, you're just introducing another chance for something to go wrong. And that brings us to one last question for you to think about. After seeing this whole balancing act, think about your next project. If you were forced to pick just one thing to prioritize above everything else, blazing speed, perfect accuracy, or rock-bottom cost, which would you choose? There's really no single right answer, but whatever you decide will define everything that comes next.